Alright, we're gonna pretend that that last bit didn't happen. My name's Tom, and welcome to a live Python programming stream where we're gonna be doing Advent of Code, and my pop filter is hopefully not gonna keep jiggling around like this. It's very cheap and nasty. It's a stocking over an embroidery hoop. We're gonna just live with it, because if I'm very careful and I don't bump it, it's gonna stay still. So today we're doing Advent of Code. It's the 21st of December. I haven't done any Advent of Code yet. And we're just gonna sit down and I'm gonna do as much Advent of Code in Python in one sitting as possible. It's gonna be fun. It's gonna be good. I'm gonna talk about algorithms. I'm gonna talk about how I think about this kind of problem. I'm just gonna share this link to a few of my loyal fans. Huge thanks to everyone who hangs around in my Discord, because I certainly don't. you know, it's been a weird year. It's been a rough year. Things are going to be changing. The background here is going to be changing. Everything's going to be changing. Next year is going to be a new year. I'm currently unemployed, looking after my health and my well-being, but there's definitely time to do a little bit of streaming in amongst that. I'm focusing on things that definitely aren't programming at the moment, but I still love coding and I still want to do programming. So just while I crap on and get things ready, announcements. Sick. All right, that's enough. Let's just start. Let's just go. Okay, so we're gonna jump over. I was making dummy files. This is the Advent of Code website. If you haven't done Advent of Code before, it gives you a problem every day in December, I guess. I've never actually done them all before. I usually peter out somewhere. But you know, the 22nd is going to come out in 18 hours. You can compete with your friends for who can get the answer first. I want to start with day 1. In the past, I've done this in Haskell. And Haskell is a really fun language for this kind of problem. But because I just want to try and smash out as many as I can, I'm not trying to be clever today. I'm just going to sit down and do it in Python, a language that I'm very comfortable with and I'm very good with. Day 1 trebuchet. Something's wrong with global snow production. I love the theming of these as well. The theming is always a highlight. You've been selected to take a look. The elves have given you a map. On it, they've used stars to mark the top 50 locations they are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars. Oh, yeah, cool. Check them, blah, 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 blah. This is just the setup. Okay, so try and answer why they can't use a weather machine. This calls back to previous advents of code. This is fantastic. Your map looks mostly blank. Did you just say the sky? I was already loading you into a trebuchet. They're making the final adjustments. They discover the calibration document has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value. So it's lines of text. Each line is a calibration value that the elves need to recover. For each line, the calibration value can be found by combining the first digit and the last digit to form a 2-digit number. All right. First digit, last digit. Cool. Sum of all the calibration values. Okay, so day 1. What am I calling my files? I'm just going to call it a.py. Screw it. So we can't use the word input. We can't use the word in. Let's just say t is lines. Let's copy their example. This is always the way to go. I think I can do multi-line strings like this, right? This is how Python works, isn't it? Okay, so for each line, find the first digit, find the last digit. So we want a function. It's going to take a line. We can actually do this as like a weird one-liner. Let's write a function because that's a little bit cleaner. Digit get. We'll call it get digits. It's going to take a string. So an input to this is going to be one of these lines. We want the first index that's a digit and the last index that's a digit. What's a good way to do this? I mean, some kind of filter, I guess, and then filter the string down. This isn't very efficient. Let's let's write the dumb solution first. I think the dumb solution is always the best way to start. So let's say for each character in the string. In Python, this is weird because these characters are themselves strings. I'm going to be really dumb about this. If first... So what we're going to say is for every character we go through, if C dot... I need to pull up a REPL for this. I can never remember with Python what these functions are called, but this one is isDigit. So we have a function isDigit. If C is digit, maybe let's say if not C is digit, continue. So for every character in the string, if it's not a digit, we don't care, ignore it. Then we're going to say if we haven't found a first digit yet, first is... Again, we're going to double convert here, and then we're always going to set last. Right, so for every character that's a digit in the string, we'll set last to that value. That way the last digit in the string, by the time we've exited this loop, will always be whatever digit we found last. We could make this better by not calling int twice, but again, dumb solutions are the way you get this started. So then we'll say answer equals, again, I need to remember, I guess I split on new line. I thought there was a lines function in Python, but maybe I'm wrong. Split. So for each line in the input, we're going to map a getDigits function, except that's not how Python map works. We have to do the map here, getDigits. And then we're going to map over this lambda xy. I suspect Python does not let me unpack like this, but let's find out. There's only one way to find out. Maybe I can... We'll find out. We'll find out. There's probably like some magic I can do here. And then we sum those together. Okay, so what happens when I run this? It doesn't, yeah, expression parameters cannot be parenthesized. Let's see if Python's smart enough to unpack a tuple, because we're returning a tuple, right? We're returning these. I guess the other option is we just simplify this even more, because this is saying that we... Oh no, sorry, we combine them into a two-digit. We concatenate them together. It helps if you read the problem. This is the real test. Can you actually read the problem? Calibration value, combining a single two-digit number. So actually, the two-digit number is going to be first times 10 plus last. Because we know they're only one digit each, because of how this all works, this is okay. This is how you do it. And then this just disappears and we just sum it. And then we have too many parentheses, of course, because we got rid of one. And so what I'm trying to actually say here is if first is none, then we haven't found a first digit yet. What I'm saying is if first is not none, first is none. It's never going to get set. It relies on it being non-none to set it. That was just a typo. This still isn't getting set. This isn't getting set because if first is none, so that might just mean that this is always getting hit. Let's do something silly and just print C. A healthy bit of debug printing just to get us going here. Nothing gets printed. See, so what's happened here, right? What's happened here? What's happened here is we have an empty line. It is literally this simple, I think. We're passing empty string in and it's blowing up, maybe. Also helps if I don't quote that. Skip. Everything's getting skipped. Except for digits. No, digits are okay. Bobbius, hello. Thank you for stopping by. I have made a silly mistake. What silly mistake have I made? I mean, if this was failing, it would throw an exception. Why is first none here? Why have we not found a first digit? Because it looks like we definitely have... Oh, well, hold on. I mean, this is the other thing, right? Yeah, okay. So we're just somehow skipping straight through to the end for this string. That makes sense. So why? The joys of text processing work. Yeah, I've just done something silly here. Some without regexes. Yeah, I guess. I don't know. I don't know last numerical digit in a string with regex. You can do that, but that's not the kind of regex I like to write. It's the kind of regex I try to avoid. This also has this annoying thing where standard in and standard out, standard out and standard error, sorry, are not behaving. Okay, so that makes sense. Funnily enough, the edge case here has also been caught just by my algorithm without me thinking about it. 7 is the first and the last. Okay, how about we do the opposite? This logging is too noisy to be productive. What we're going to say instead is... C. Where else am I printing here? I don't need to print that. Okay, there we go. First digit 1. Oh, it's literally just the end line. It's literally just the end line. Because we're just summing things up, we can skip things like this. We could also say filter lambda x len x greater than 0. This would also avoid this problem, but that is beautiful. That makes so much sense. You can tell I haven't been writing much code lately. Cool, and then we just want to print answer. And this gives us 142. 142 is the answer we expect. We can get rid of all our lovely debug printing. But yeah, so I'm unemployed and I haven't really been writing code for like 2 months. So I also have motivation to do this just to keep my skills sharp. Excellent. So this is a nice little solution to day 1. Nice little mystery bug with a 0 length string, meaning that this never triggered. So we got to this part, this statement where first was still none. We were trying to multiply none by a number, which of course doesn't work because Python does have types, even though they're sneaky types. Not quite as sneaky as JavaScript types, but they are sneaky types. Bobby has solved this in Rust. They used a regex to grab the first digit, then reversed the string and used another regex to grab the first digit. That's probably less lines of code, but in my opinion, perhaps a little bit less elegant. Let's grab my puzzle input. I assume this is different for everyone, right? I actually don't really know. Okay, so we'll just copy paste this. What am I doing? Edit, input. 1,000 lines, that checks out. Yep, that'll fit on my clipboard, luckily. Okay. I don't know why I have this side by side, hold on. that really cramps things out. Wonderful, wonderful. What am I doing? We'll make this properly runnable. We'll write nice code. I don't need to do that with open input as f. This is where the lines function is. It's not a method on string, it's a method on the file, I'm pretty sure. Or maybe not. I swear there's an iterator here. Can I just iterate over f? Is the file an iterator when it's open in text mode? Is that how it works? I think so. How do you, what am I doing? What have I done wrong? Also, hold on, I've done something real weird here. Python read lines, is that it? f.read lines. List containing each line. Yeah, cool. This isn't that's the best way to iterate over, oh, for God's sake. Not the best way to iterate over lines in a Python. Let's just like do a really dumb wrap here. And of course it's empty string, right? Of course it's an empty string. So let's just say if s is empty string, and does this still happen? It does. Is this a white space string? It is. There's a line with a space in it. There's a line with a space in it. That'll always do it. Excellent. Excellent. That took longer than it should have. But these things always do when you live stream. Cool. So that was the correct answer. We summed all the things up correctly. Beautiful. Part 2, your calculation isn't quite right. It looks like some of the digits are spelled out with letters. Oh no. Oh no. This is fine. This is actually fine, okay? So this test case, let's do this in a separate file. We'll make a new test case here. Cool. So we'll go back to this is a really janky way of swapping between tests and files, but it's fine. Now when we say is digit, we also want to check for C being a number string. So if C is not a digit or not is number string C, right? Hold on, no, but these are characters. Shit, hold on. Okay. That's I guess we could split the string, or okay, this is where iterating over everything becomes more problematic. We want the first instance of a thing. My approach is not as flexible here as I hoped. Yeah, exactly. Bobbius's approach here of searching the string from the head, then reversing the string and searching back, searching with the head again rather, is more flexible here in this case, given this follow-up. I'm usually pretty good at my approaches going over to the second part, but not today, not today. So we're going to delete all this, okay? Get to just S. So, I mean, yeah, the reverse, I would like to avoid reversing the string, if possible. Also, reversing the string doesn't work naively here because you have to look for the names of the letters reversed, right? So 7 would be Nevis. Yeah, and you would have to make a second regex, right? Which is doable. What's a way of doing this that doesn't involve reversing a string? I guess it's finding all indexes that match it, but I don't like that. What I really want is to split the string on every digit or block of letters. Fuck it, do I just reverse the string? This is more of a thinker than I thought. Okay. I like the idea of splitting the string on digits or things that, like words that spell out digits. This is harder than the first ones usually are. Or I'm rusty, which both are possible. This is also a fun edge case. Okay. So. So let's say Python string split on, but it's not just a predicate, is it? Because a predicate will just work on a single character. This is a more holistic view. Yeah, reversing the string is a very homogeneous approach. Like you do the same thing twice, which is quite good. I mean, it's not going to change the complexity. It's still going to be big O n, even if yours is like big O, some like m times n. Like it's a like 3n or whatever. Like there's probably a smart one iteration solution, but it's more code and like it's just unnecessarily complicated. You don't win a prize for being more efficient here. You win a prize for getting an answer. 2, 3. So is there a general... So, because in Python, you get... Oops. So there's a string dot find, right? Which tells you the index of a given substring. Is there a find? What am I trying to say? Is there a function... That doesn't work either. I'm trying to put the shapes of this together. Inputs are short enough. Yeah, the inputs are never too huge, right? The inputs for Advent of Code are always designed to be the kind of order of magnitude, right? Like one order of, if your algorithm should be, like log n, and you write an n squared algorithm, it might fail, but it's never going to be like, being like 2 log n or something is going to make you too inefficient. It's in that kind of like complexity family. I'm gonna think about this, and I'm gonna move on to day 2 for now, cause that is just a little bit too time consuming. I'll think about it. I might come back and just do the string reverse thing, which probably most people did. But I have this taste in my mouth that there's something else I can do. Okay, cube conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay. Put them back in the bag. So he's going to reach in, he's going to take cubes, he's going to put them back in the bag, so we're randomly sampling from the cubes in the bag. Sorry, I'm trying to drink a little bit further away from the mic. Oh wow, Bobby's wrote a brute Forced solution. Comparable solutions took days to run in the cloud. Yeah. But there's probably a smarter way, right? There's probably like an algorithm that you're missing. I think. I don't know. I always peter out before the end. They get kind of tricky. Okay, you play several games, record the information from each game. Each game is listed with its ID number, 11 for game 11, followed by a semicolon separated list of subsets of the cubes that were revealed from the bag. Record of a few games. Cool, so we've got to write a parser for this, and that's okay. This is simple, this is just n color. Okay. Which games would have... The author would like to know which games would have been possible if the bag only contained... Okay, that's okay. Okay, okay. This one isn't too bad. All it's asking... I'm guessing there's a second part which is going to be a lot worse. But first we just need to parse this. So that is fine. We're going to write a function parse line, which is going to take some string. So the sections are, the first section of the string is everything before the semicolon, which is the game. Everything after the semicolon is the set of draws from the game. So we'll say... let's say game part, let's call it tail, is s split. And I think we want 1 here. I think this gives us a nice tuple that we can unpack like this. And then we want to, what is the terminology they use? Okay, semi of subsets. Let's say reveals is tail split. So split the rest by the semicolons. And we'll write another function, parse reveal. I don't necessarily love this, but it'll do. And so a reveal is going to be this part, which is a comma separated list. So the first thing we're going to do is say cubes is s split comma. For C in cubes, n color. I might want 2 here instead of 1. I can never remember the Python API for this. Let's check. Let's check while I go. So let's say foo bar split. If I split this on a space and I pass a 1 here, cool, I get a nice. If I put a 2 here, okay, yeah, fine. So this is kind of like at most 1 split. It maybe isn't actually necessary. I don't know. We'll see if we can unpack like this. I'm pretty sure you can. So this should give us the colors, and they're in random order, so we have to do it like this. The question is how we kind of model this as well. I guess we just do, so let's say, let's just make a crappy enum. And we're just gonna return, actually, let's do this. Red. I might not have trimmed all my white space to make this work properly. Cool. So we map this into a dictionary. And we're gonna abuse tuples here pretty heavily. Except that's not it, is it? That's not what I want at all. Oh, hold on. Actually, no, hold on. Whoa. Because because we're drawing out of a bag, this is implicitly 0 green, 3 blue, and 4 red. So what we're actually saying, let's say culls. This is better, okay? So we're going to return a dictionary that has these as keys. And we're going to set the number of cubes we saw. And we only expect each of these to be seen once. Bobius doesn't understand why Python doesn't have language level enums, and I don't understand either. It's very upsetting. Just wait till you try Go. Okay, so each reveal. So then for reveals, cool. Actually, we can just say we can cut this down a little. So we're gonna get a list of dictionaries where each dictionary is the number of green, red, and blue cubes that we've seen. And there's only red, green, or blue. And that's fine, that's fine. Okay, so then we want to cubes valid. Oh, but we need the game ID as well. Hold on. Oh, that's okay, that's okay. Game 1. Game 3 would have been impossible because at one point there were 15... 20 red cubes, sorry. Okay, yeah, so this is fine, this is fine. So we want to filter, no we don't. Let's finish parsing. Let's not be too silly, okay? So let's get the game number. Which is the bit after the space. Let's also put a 1 here just to be safe, and then let's say game number int. Okay, so we're going to keep this nice and separate. We're not going to tie any logic up in here. And we're just going to try, we're going to see what we get if we print excellent. Excellent. Let's manually unpack this into a list. Invalid int. So this is likely a problem with me not dealing with padding properly. And indeed, there is a space here. So what we want is to just liberally sparkle s is s.strip. Just some strips around here. S. Just make sure any white space is getting axed. C equals c.strip. Perfect. There we go. That's it. So this line that I put in 3, 4, 1, 3 blue, 4 red, 1 red, 1 green. So 3 blue, 4 red, no green. Perfect. 3, 4, 1 red, 2 green, 6 blue, 1 red, 2 green, 6 blue, and then 2 green, no red, no blue. 2 green, no red, no blue. Awesome. So it looks like we're pulling this out correctly. Let's now make, I can get rid of this. Let's make a test case from our example, which is over here. Cool. Now, of course, for if lem is 0, do nothing. Okay, so for each line, we're gonna say game, let's say game cubes is parse line. Okay, now we want to filter down the cubes. So cubes is a list of dictionaries, and we want to filter this. Let's say cubes valid is filter test game. If so, we'll get we'll filter out any combination of cubes that is not valid, and then if the length of cubes valid is greater than 0, if there are any valid games left. Yeah? If there are any valid games left. No, that's the opposite. Hold on. Because we're going to filter out invalid games. Let's say maybe... Let's filter out games that are valid. If there are any invalid game... If there aren't any invalid games, that's what we want, right? The existence of one invalid games means that we do not count this in our total. Answer is 0. Game. Return. Sorry. Print up. Let's see if this works. I think I've probably made errors. Yeah, definitely. Oh yeah, of course, because test game. So def test game G. Okay, and so what this is saying, so we have this hard-coded, right? 12, 13, 14. 12, 13, 14. If G greater than... Okay, let's make this a bit more generic, right? We'll make a test function which takes 3 values, which are our maximums, and then we're gonna say, so we want invalid combinations, right? So we want to return true if other R exceeds this. If the red values exceed this, if return or other green greater than G or other blue greater than blue, right? So we're making a function that's going to do this test for us. So let's say test game is make test func, and it's 12, 13, 14, sorry. So we can play with the numbers, if the thresholds if we really want to. Objective type filter has no length. We need to convert this to a list, I guess, so that the filter actually gets consumed. Here the answer is 8, which looks correct. Let's see if we can grab an input here. It's a lot of text to have, but it's 100 games. That looks okay. Cool. So now instead of this, we're going to say for oops, with instead of 4, there we go. And let's see if this is our correct answer. There is a chance it won't be. because that got a little bit flying by the seat of my pants at the end, but that was in fact the correct answer. Beautiful. Hopefully that made sense. Hopefully that made sense. I got a little bit in my own head there at the end. I went into Tom mode. But the basic idea, I think most of the problem with that was just in the parsing, right? Okay. Here we go. As we continue our walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? That's fine. As few as 4, 2 green, and 6 blue. If any color had one fewer cube... the power of a set of cubes... So, correct me if I'm wrong. So 4 red, 2 green, 6 blue. So we're looking for the biggest number in each category, right? Otherwise, it's impossible. So what this is asking is the fewest number of cubes of each color. What this question really says is what is the maximum of each color that occurs in any given game, I think. Okay. So, now we have a slightly different question. And this is okay. This is okay. This is fine. So now instead of building a list of invalid cubes, we want to get... Okay, so we want the max. Let's say RGB equals get max cube, or get most cubes, and let's write a function to do this. Get most cubes. Cool. So for C the most will be, but it's never going to be less than 0, right? We're using natural numbers. We're counting here. We're never going to have like -1. We don't have to worry about what our floor value is here. It can just be 0. So let's say most... I mean, I can do this for color in most keys. For each key, most col equals whichever is bigger between most col and C col, right? So the biggest, we want the biggest number we've seen. So the biggest number will either be the number we've already seen or the incoming number. And then we just want to return, and this saves us just writing out the names of the keys again. This is just a little bit of shorthand, but we could write this out: most red equals max most red C red. And my variable names are awful here, but we'll just have to deal with that. Most red, and the order I'm using here is RGB, which is the most common order you'll see these primary colors written in. Cool. Now let's... Oh, that also, we need to get rid of this, and then answer plus equals R times G times B. And this is good, because you can do all kinds of prime number shenanigans that make this a very unique number. The red, green, and blue cubes multiply together, yeah. Okay, so... Oh. This is why you don't use bad variable names. Also, it doesn't matter which set of keys we use. They should have the same keys, but we'll use the one we know we kind of control. Helps if you can spell ansert. I don't know what that is. 2286, 2286. Cool. So let's go. Nope. All right, it's a nice looking number. I've got a good feeling about it. Boom, 1 gold star. So gear ratios. Oh dear. Oh dear. Gear ratios are hard. Gear ratios are tricky. Okay, if you've ever done any kind of engineering, any kind of engineering, you're gonna have problems. And I'm very sorry about this pop filter that continues to rotate before my mighty breath. Bobbius, how do I sound, by the way? Just give me a shout out if I sound okay, if I need to do anything with my mic, if I need to be closer, further away. Just do please let me know, because I'm doing all this streaming. I would hate if people can't hear me properly. I played with my audio interface because I recorded some Christmas songs. Actually, maybe at the end of this stream, I'll play on stream a little bit of a recording I did on my flute. Maybe I could, I don't know, depending on how late it is. It's a little bit too late for me to actually play the flute, unfortunately. I'll annoy my neighbors. But I could play a little audio recording of some flute music that I recorded, some Christmassy flute music. Anyway. The elves, we reach the gondola lift station. He says it'll take us up to the water source. It doesn't take long to find the gondolas, but there's a problem. They're not moving. You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. So you offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number. Oh dear, this is another tricky parser, and should be included in your sum. Periods don't count as a symbol. Okay. So, in the schematic, two numbers are not part numbers because they're not adjacent to a symbol. 114 and 58. These are just floating numbers. So, I have a thought on this, just reading it straight off the bat, and that is to do this in 2 passes. The first pass, you scan through and you look for symbols, where I assume a symbol. Let's have a look at the input and just try and get a better idea of what a symbol is. Slash, dash. Okay, so basically anything along like shift top row of my keyboard, right? We'll make a generous list of symbols. Once we have a list of coordinates of symbols, we step through and we find numbers. We work out the extent of a number. And as we're stepping through, so we know the line number, we know the y coordinate off the bat, and then we work out where the x coordinate starts and ends. So we get a list of numbers and their ranges, kind of where they start and where they end and what line they're on. And then you do a n squared comparison of both lists. I'm sure there's a smarter walk you could do. Maybe you could build some kind of tree. We're not going to do that rubbish, okay? We're going to go brute force, and I don't think it's going to expect us to like build a tree for this. I mean, this is big, but this isn't like huge. I think n squared is acceptable. It might take a little minute to run, but we'll survive. Okay, so let's go. Let's go, let's make a function called get symbol positions. It's going to take our grid. For we're gonna assume we have some like object here, and we're not gonna do methods. We're just gonna do fields. That's okay. It's basically a struct, right? It's a struct, and we're gonna be able to say, let's just make our life easy when we're writing this function by assuming we have some nice helpers. So let's say, the character is going to be grid get x y. And then if char... Wait, does Python have is symbol? It doesn't. Okay. Is symbol pos dot append okay, then we're going to do a similar thing, get actually hold on, this doesn't work, does it? We're not going to have this because our numbers don't nicely align to the grid. So let's rethink what we're doing. Let's make something a little bit easier. Get line symbols. This is going to take a line number and a line. We could put this on the outside and zip it in later, but I don't want to like map a zip. Cool. Get line symbol. Bobbius in chat with a big help there. A symbol is anything that isn't a dot or a digit. This is true. This is actually this is another one of these things that isn't specified, but it is. I think. Hold on, unless I can't read. But that, you know, I can't read. So that's a real problem. Okay, for each character in our line, if I'm still going to write a function to encapsulate this logic just because I think it looks nicer. If it is a symbol, pos append I also just need to check the order. Let's say list. I'm pretty sure it's index then character. That is correct. Okay, so for each index, let's say I line number. So we're going to run this for each line to get the positions of symbols on that line, and then we're going to add all those together. This one's going to be harder. So let's say nums for IC in enumerate line. Okay, so for every character in the line, we're going to have an accumulator. We're going to accumulate digits into an accumulator. If is digit C. So if it's a digit, we just add the digit into the accumulator and we keep going. And then if we've fallen out to the end of a line, we say that... fuck, hold on, we need to remember where the number starts though. Let's say start index. Let's say -1 just for the fun of it, if I can find where my minus key is on my tiny keyboard. It's hard, right? When you stop typing on this thing all the time, it gets harder to remember where buttons are. But I'm picking it up again. Okay, so here we go. When we find a digit, if the accumulator is empty, then start index is the current index. We add the character in, and we keep going. If we fall out the end of the loop, if the accumulator is not equal to the empty string, then we need to add whatever number we've accumulated in. So we say nums append start index len line -1, I think. Because you never have length -1 and then int. Okay. Similarly, if what we have is not a digit, then if the accumulator is not an empty string, I don't like this bit of duplication, but it'll do. We say that we append the number. So actually, rather than a continue here, we can just say else. Start index, the current index -1, except it's diagonally adjacent. That's fine. Because it is the current index -1, right? We've hit a thing, the number does not bound to here. So, for example, 0, 1, 2 this number does not range to 3. So it starts at 0, it ends at 2. That's fine. And then the value is going to be whatever's in the accumulator. And then we say the accumulator is empty string. Now when we find our next digit, the start index will be updated because the accumulator is empty. If we find the end of the line first, before we find another digit, then the accumulator is not empty, so we don't add anything to our list, and then we return the numbers. Okay, so we can parse this into a list of positions. Ah, fuck, hold on, but we need a line number as well. I love a good unwieldy tuple. You really know that you're doing Advent of Code when you've got a healthy unwieldy tuple. That's when I know the festive season's really started. Okay, so we need to define is symbol. And this we actually don't need to do like this at all. Is digit, we already used this today. If is symbol C, return C not equal to period and not C dot is digit. So C isn't a digit and C is not a period. True. Yes. Good. I am so sorry about this pop filter. It's annoying me. I'm sure it's annoying someone watching me. I just continue to headbutt it and also just move it with my very vigorous breath. Okay, so if name is main. Whoa, there's a little stray quote there. Let's get this test case going. Let's make sure we don't have any weird stray characters. Okay, so for line in t.split. Again, we're going to use this enumerate. If you don't know what enumerate does, you should really learn how to use it because it's a real superpower for a very specific set of things. And again, like I could actually use a zip to put this in after the fact rather than passing it through as an argument, but this is just cleaner for the level of brain power I have today, apparently. Unfortunately, I'm probably going to do this one and then bounce, but these have been good fun. I was hoping to blast through a few more. This has gone a little slower than I'd hoped, but this is what happens when you don't write code every single day, I guess. You get rusty. But these do just take time, right? They are tricky. They make them hard. They make them fun. Bobbius, I think we would have less awkward tuples if Python had better struct support, and it does have struct support. Don't at me, Python lovers. I know it's there. I just don't know how to use it. I fear data classes. Okay, I'm getting distracted. I'm getting tired. I've got to be on a plane tomorrow. For every line, we're gonna say. Okay, well, actually, let's do this in one pass. Sims, nums. For each line, let's say sims plus equals get line symbol. We're going to pass in the line number and the line. And then nums plus equals get line numbers. I'm going to pass in the thing and the line. And then we're just going to print the location of the symbols. We're going to print the location of the numbers. And we're going to see where this blows up because it almost certainly won't work. Perfect. None-type object is not iterable. None-type object is not iterable. This is because I forgot to return anything up here, right? So this is something you see in Python a lot, right? This cryptic error, when you're trying to like append something to a list, none-type is not iterable. And you have to think, what would be none here, right? Is this none? No, I set it to empty list. How is this none? Well, in Python, when you don't return from a function, it just quietly returns none for you. So this is definitely like a Python gotcha that you will see, and it will catch you up. Nice. Okay. Position of symbols. 3, 1, 0, 1. So 0, 1, 2, 3, 4. 6, 3. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. Somehow these are off by 1. That's weird. That's very weird. Like, this isn't, this isn't, huh. What I'm trying to say is, this isn't Lua, right? We're zero indexed. So something has gone astray here. Because this is 0, 1, 2, 3. Wait, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2. 0, 1, 2. I think I need my glasses on. This is hard to read. 0, 1, 2, 3, 4, that is right. So, okay, this looks correct. This looks correct. And then our number 464 starts at 0, goes from 0 to 2 on line 0. Beautiful. 0, 1, 2, 3, 4, 5, 6, 7. Beautiful. 35 goes from 0, 1, 2, 3, 6, 6, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 6 to 8 on line 2. Okay, this is good. This is good. Now we need to do this pair adjacency test. Okay, so the advantage here is that for everything we find, okay, so for each symbol we want to loop over the numbers. Let's say for S in Sims, for every symbol, let's say for X, Y, so for every symbol position, for num in nums, again, let's unpack this here. So this is start and if in range start and again, let's just double check range. So we want, so if it starts, so if we have 5, 7, for example, this is gonna say 5, 6. We want it to check index 7 as well. So if we say 5, 7 plus 1, we get this. This is maybe not the most elegant way to represent it, but so be it. If is diagonal, if it's a diagonal, let's say x, y, start, and, or let's say is adjacent, then we add the symbol and we need to continue the outer loop. We need to continue at this loop. So let's say let's say answer, answer, so we say answer plus equals value. We add them together, their sum. And then we need to okay, here we go. Python break outer loop. Yeah, okay. Python doesn't have this kind of like a label and stuff. Is there a better way I can wrap this up in a function? That is the easiest way to do this kind of thing. That's the easiest way to do it. Oh dear. The problem is I can't just have like a variable and check it. Actually, no, I can. Hold on. Next sim is true. for every symbol. Cool. So if we've found an answer, don't look for any other numbers. Just keep going. And numbers can match against multiple symbols. That's fine. Print answer. And now we just need a function that tests for adjacency. That's the only thing we're missing. So it's x, y naught, x1, y1. So it takes two pairs of points, and we need to know if x naught equals x1. Let's break this down into two parts. A, B. A equal to B, or A equal to B plus 1, or A equal to B minus 1, right? That's what we're saying here. Because it's either equal or it's 1 to either side. Return adj and adj y0, y1. Right? I think that's right. This says the answer is 149. That is not correct. That is not correct. Okay, I've done something wrong. And the wrong thing I've done is probably in the adjacency test. And let's verify that by when we come in here, print number what am I? Number let's remember to close our brackets. It does not find enough numbers. I noticed these are only finding things. 35 is adjacent to 5, 8, 0, 1, 2. That doesn't seem right. 35 is adjacent to 3, 4. 0, 1, 2, 3. That's not right. I want it to be adjacent to. So 35. Hold on. Start. By my definition, this does look correct, doesn't it? 35 is 0, 1, 2, 3 on 0, 1, 2. Zero, 1, 2, 3, 4. No, but that isn't. Hold on. That isn't right. That isn't right because 2 isn't adjacent to 4. 2 isn't adjacent to 4. So why does it think 2 is adjacent to 4? Why does it think 2 is adjacent to 4? X, Y is... I end? That still doesn't make sense though. That looks better. But it still thinks 35 is adjacent to 3, 4, which, again, and it also thinks 1, 1, 4 is adjacent to something. So it looks like adjacency is only counting the X. It doesn't look like Y matters fucking at all. 5, 5. This is 5, 5 though. 0, 1, 2, 3, 4, 5. So this one is because that makes sense. It should find... Okay. One step at a time. Why is Y not factoring in? Because this is an AND, right? Hold on. I'm going to run to the bathroom. Okay? And then we're going to work this out. I will be back shortly. I've worked it out. I've done it. Well, not worked it out, but I've worked out what I need to do to go forward. I don't want to exaggerate here, okay? So, what I'm going to do is, from a import star, let's just play with which is a function. Because I don't want to type it out every time, let's just alias it to f. So, we have the point 0, 0. We expect 0, 0 to be adjacent to that. True. We expect the point 1, 0 to be adjacent to that. We don't expect the point 2, 0 to be adjacent. Likewise, we expect negative 1, 0 to be adjacent. We don't expect negative 2, 0 to be adjacent. Okay, that's great. Now let's move over to the y-axis. We expect 0, 1 to be adjacent. We expect 0, 2 to be not adjacent. We expect 0, negative 1. So all good so far. What about 1, 1? What about 1, 2? Okay, so this looks good, right? This looks good. This is correct. This is incorrect. What's the example? It's 2, 3, 5, 3, 5. So this looks like it's doing the right thing. That's good. That's good news. This function is correct. Let's make sure we're doing this range properly, but that makes sense, right? So 2, 0 is adjacent to 3, 1. That is correct. 2, 2 is not adjacent to 3, 4. How does this happen? How does this happen? Yes. End is not a y coordinate. End is an x coordinate. End is this x coordinate. So actually what we were saying was 2, 3, which is adjacent to 3, 4. We were ignoring the y coordinate entirely. So what we want is this line, and now if we run this, we're going to get still the wrong answer, but a closer answer. We're edging closer, okay? So 2, 0 is adjacent to 3, 1. That is fine. So 114 we don't see, and 58 we also don't see. That's good. What number is missing? 633, 617, 592, 755, 64, 598, however. Oh, it's because multiple numbers can be adjacent to one symbol. So actually, let's just get rid of this. Now we're overestimating. Hold on, wait. I had this for a reason. So what are we doing? Lots of numbers. Any number adjacent to a symbol is a part number. Bobius sympathizes with me. Still too low, but closer. You can taste it. You can taste it getting closer. Okay? There's good things happening here. In this schematic, the numbers are not part numbers. They're not adjacent to a symbol. So for each symbol, I want every number adjacent to that symbol. So in other words, my list, because of how I early out, does not include 35. So am I just looping inside out, right? Do I want for each number to do this? Yeah, that's the right answer. Okay, so let's try it with the input. That was intentional. I am not confident that this is correct. Let me make sure this looks right. Looks like I've copied everything. Good. I just always like to make sure my clipboard is big enough. Okay, let's go back here. Now instead of t-split with open, helps if you close your brackets. Lines is f read lines. Nice. That did not take very long. Answer's too high. We're overcounting. I was worried about that. I was worried about that, but I wasn't sure why I was worried about that. Okay. Let's go back. What are we doing here? For every number, we're checking each symbol. Then we're checking... Okay, well, first off, It doesn't matter. It'll just multiply, so that's fine. For every symbol, we're checking every number. But that's fine. That should be, like, we don't want an early out here, right? That doesn't make sense. Because we want to find every number can only be adjacent to one symbol, right? No, sorry, hold on. We only care if a number is adjacent to any symbol. So the first symbol we find, we want to stop checking. We want to start adding this number. We only want each number to appear in our output once. I guess the other thing we could do, right, is get rid of this, and instead of adding the value to an answer, we get... Okay, let's try this. Let's do my favorite thing and make a set. Okay? Dot add. This means that each number only appears once. And then we can just add together all the things in the set. I think this actually solves our problem. This is a smaller number. Answer's too low. Shit. Hold on. That's not good. Do I still get the right answer here, at least? No. Oh yeah, I do. I get the right answer here. Okay. So, something has gone wrong. I like this though, because like we're just massively oversampling and it doesn't matter. And that's good. We're finding numbers are adjacent potentially to many different things, or individual digits in numbers. Like 35 is adjacent twice because both of its digits are adjacent. I guess we could say break here. That would remove some of the duplication, and here it removes all of the duplication. Each number is only adjacent to one symbol, but if I come in here and I modify this a little, and I put this here, for example, we're going to find that numbers are adjacent to multiple symbols, right? 664 is going to be adjacent twice. However, it should not impact the outcome. This does, however, make 755 no longer adjacent, so we get a different answer. So here, even though 644 appears twice, it doesn't impact the final answer because we're using a set. This is the magic of the set. Sets only contain unique elements. You can add duplicate stuff to a set till the cows come home. They will only count once. Okay, so this seems right. This seems good. We're dealing with a case where a number is adjacent to multiple symbols. We're not doing any weird early out shenanigans. Why? Oh, let's return this to its natural state. Three 7016. And that's not correct. Your answer's too low. Okay. Why am I undercounting? What could I possibly be undercounting? I don't know how I'm meant to manually parse this. So, I mean, yeah, look, this is just like too much data to comprehend. So like, okay, let's try this. So 349 and 95 are both adjacent to numbers. So 349 is here. It's here a couple of times. That's kind of weird. Oh, okay. It appears... Oh! Okay, so I misunderstood. This is an inappropriate use of a set. What? Oh, I still have these open. Hold on, let's... Okay, let's let's put these in the correct folder, at least. Okay. Let's see now. I think the problem was that I wasn't breaking after finding each number. Hopefully this is right now. I think my algorithm is good. Shit. Oh, that's so annoying. Set, though, definitely was the wrong approach. Four, 3, 6, 1. Interesting. Okay. I don't want to give up. I don't want to leave this unfinished. The existence of duplicates here. What am I doing? The existence of duplicates here makes this more complicated than I thought. But that shouldn't matter. That really shouldn't matter. Oh, what have I done? 566. Let's just like pick some random numbers, right? 566 appears once. Oh no, there it is. There it is. 49, 45, 49. That looks about good. Okay, so how many? So there's 4, 3, 4 9s. 1, 2, 3, 4. That looks good. What about 399? I'm just going to go through and find numbers that might have interesting 2399s. 36, 2014. Make sure I've like entered the number correctly. Okay, so I guess what are... So what am I saying here? What am I saying? For each number, check each symbol. If this number is adjacent to the symbol, then add the value of that number to our answer and keep going. But we need to break again. We need to break. We do actually need this. Because then if you have this case, where's an example? I don't know if I can see a good example easily, but say there was a star here, that wouldn't change the answer. So actually, we can do this. We can demonstrate this like this. This will now give us the wrong answer if we run it with this test case. Because we're going to add this number in too many times. Right, we're going to add this 592 in twice when it should only be here once. So the problem isn't it's deduplication, but it's deduplication based on position. But that's not as... Like, we can just break the loop. We can just break the loop. And we break the loop here instead. So if next sim, then I think, right? Because the number is next to a symbol. So here I was doing the symbol loop on the outside, which was not correct. But now the number loop on the outside, this break, is correct. So that was a really minor thing. I kind of tripped myself over in order, and this is an answer I have not yet submitted. I think that last one I actually had submitted before, which is annoying. Oh, I've got to... Okay. I've got to wait. That's cool. That's cool. All right, so I'm going to submit this, and then I'm going to call it a night, because I'm getting tired. I am running out of steam very quickly. I've got a little bit of housework to do to get ready for Christmas. I hope everyone is doing well and is ready for an exciting Christmas. I'm hoping to do some streams next year and just work on some fun stuff again. Because, not working as a programmer at the moment, it would be good to keep my skills hot. I don't want to forget how to write code. So I want to do some coding. I want to have fun. I've been playing with some Rust in my spare time. I've written a little text-based roguelike to run on the PS2. I've done little bits and bobs, but I haven't been sharing it like I normally would. Oh, are you kidding me? Okay, that's annoying. I feel like this should be the right answer, right? I feel like I've done everything right here. So annoyingly, I am gonna have to leave this one unfinished, which is driving me kind of crazy. Okay, no, I'm gonna try one more thing. I'm gonna try the smarter deduplication, right? I'm gonna make answer a set again. So let's say numbers that are adjacent. We're gonna make it a set. I guess do tuples have like uniqueness like this in Python? I don't know if they do. We'll find out. Answer add the value, the start position, and the line. This uniquely identifies answer edge. Nums. And then the answer is going to be the sum of the first index of the tuple from the numbers that are adjacent to things. And of course, we have an unmatched. Wait, where was that? There it is. Oh, sorry. That is silly, isn't it? You can tell I'm getting tired. Is that the number? Hold on, what did I just submit? 54373. This is the one I submitted. This is what I... Did I get a bad input? Can I complain to Advent of Code? What have I done wrong? That's so weird. Unless the tuple set thing doesn't work like I expect. Anyway, I'm gonna have to call it there. This was unsatisfying. I have done better in previous Advent of Code streams. These were tricky. This one's tricky. This one's got teeth. Man, it's so frustrating because it feels so solvable and it feels like I actually have an answer that feels correct. Like it passes the test case with flying colors, and a few tweaks to the test case I can make it pass as well. Does this pass the test case? 4361. Yeah. Okay. So I don't know. I don't know, man. Shit's complicated. Life's hard. Nothing's ever as easy as you want it to be. Man. So I hope everyone has a great Christmas or whatever you do at this time of year. And I'm hoping to come back and do more streams. Whew. Yeah, man, these have been tricky. Bobbius, thank you very much for hanging around. It's been good having someone to keep me company while I stare into the abyss. Bobbius says these have been tricky in the early days. They really have been. I've been telling one of my friends, like, yeah, check out Advent of Code. It's good. It's chill. You know, you just get to do Python problems. You can brush up your Python skills. These are freaking hard. Maybe I should just, like, keep sending them to people and don't tell them they're hard. And then if my friends solve them, I know they're, like, genius programmers, right? Get them in touch with my mates, give them a job. Okay, that's it. I'm done. Thanks for watching. There'll be more later, as in next year. Looking forward to a strong 2024 of streaming. I'm going to do it more seriously. So stay tuned for that. because I don't want to forget how to program while I'm taking my my gap year, my very late gap year. All right, I'm just gonna keep talking. Thanks for hanging out.